Hi guys, welcome back again to my YouTube channel. In this video I'll be proving this by this guy, a French guy called Demore. Yeah, today we're gonna be proving Demore's theorem. So quickly we're going to use mathematical induction to prove this. So before wasting any time, let's go ahead and quickly prove that here are the steps that we need to follow. Firstly, we must prove true for n equals to 1. We must assume that n is equals to k such that k is some integer. Then prove true for n equals to k plus 1. So let's go ahead and test for n equals to 1. Step 1. Prove true for n equals to 1. So here in my left hand side, here I will have r times cos theta plus I sin theta to the power of all raised to the power of 1 equals to let me quickly wipe all these to create some room. Let's create some room here. So let's have this one here is going to be r to the power of 1 cos of 1 times theta plus I sin of theta times 1 instead of this n here. Oh, there's an n there. So it is indeed true for n equals to 1. Step 1 proved. Now step 2. Here on step 2, we're going to firstly assume that n is equals to k, given that k is found in integers. So wherever we have n, let's substitute k there. So let's have r cos of theta plus I sin theta to the power of k in this case. Instead of that n, I will use k since I have assumed that k is indeed equals to n. Then here I will have r to the power of k times by cos of k times theta. Yeah, this is theta. This is theta right here. This is theta plus I sin of k times theta. Okay, now let me step 3 now. This was step 2. Now we are on step 3. Now step 3. By now, suppose we all know the mathematical induction proof. Okay, so proving style here. Here we're going to prove true for n equals to k plus 1. Now n equals to k plus 1. That is, we are still using that equation there. So wherever we have n, we are substituting k plus 1. Okay, cool. Now we're going to have r cos of theta plus I sin of theta to the power of all raised to the power of k plus 1. So now this right here this is going to be equals to r to the power. Okay, before coming here, let me quickly remind you this. Remember, if we had something like 2 to the power 2 plus 1, we know that this is equals to 2 squared times 2 to the power 1. Then according to the laws of exponents, if the bases are the same, then you simply add, you keep one base, then add the exponents. So now in this case we have two bases that are this, we have the addition of exponents, meaning before coming to this was like r, this was r cos theta plus I sine theta, close that, to the power of k times r cos theta plus I sine theta. This was like this. Okay, now so if we can look here, if we can notice, this right here is equals to this right here, and this right here is equals to this right here. I'm not sure if you get this. This is equals to this, right? And if this is equals to this and this is equals to this, then this is equals to that. You get this? Yes. If A is equals to B and B is equals to C, then A is equals to C. This is what I mean. This is what I mean. So now instead of this, let me substitute this guy right here. So I'll have r to the power k cos of k times theta plus I sine k times theta. Now I close my bracket, then I'll have this guy here. Then I will have r cos theta plus I sine theta. Then I will close that too. Let's go. So this is then equal to, okay, let's check now. R times R is going to be R times r to the power k is going to be r to the power k plus 1. Then these two going to multiply each other, so that is this is gonna multiply this, and this is going to multiply that too. This term will multiply all this, and this term will multiply all that. So let's write that down. What I'm saying is that cos of k theta will multiply all this here. Will multiply that cos theta plus I sine theta plus, then this guy will multiply all these two. So I sine of k theta will multiply, this guy will multiply all this, so cos theta plus I sine theta, then square that, right? So I'm not sure if you can still see this. Yeah, so now what we're going to have is that we're going to have r to the k plus 1. Then let's do the FOIL now. This times this is going to be cos k times theta times cos theta. Then this times that is going to be plus cos theta. Oh, it's going to be cos k times theta times this here I sine theta. I hope people are still following. I hope people are still following, right? I'm just doing the foil. I'm just distributing these. Now I'm done with this part. Let's focus on this part now. So this times this is going to be plus I sine theta cos theta plus. Let me just add this here. Let me just add this here. Or no, let me just create some room. Let me create some room. I'll start from this step.